For the magnetic effect, electric current, just we discussed about electric current. Here when you see about this is what electric current. Electric current I is equals to what's the formula? Q by T. It's a Q by T. So Q is what? Net flow of charge. It's a net flow of charge. This is net flow of charge. T stands for what? So time, unit time, like. So net flow of charge means what is the net flow of charge? Net flow of positive charge. Okay. So here again we discussed about I is equals to, that's what, Q by T. It's what? Coulomb per what? It's a second. 1 coulomb per 1 second is what? 1 ampere. This is the thing. So for the ampere, so ampere means from this ammeter. Okay. So what is ammeter? Ammeter is a device. Ammeter is a device. So the ammeter is a device which is useful to measure what? It's a current. Okay. So it is a device. It is a device. So to measure so current in the circuit. It measures current in the circuit. So this is what? It's a ammeter. So for this ammeter, if you are discussing about it, how do you connect the ammeter and what is the symbol for this ammeter? Okay, so it's what? This is symbol for ammeter. If you connect to this one positive, this one is negative, it comes positive and negative. Individually it doesn't have any positive and negative. Like this, for example, this only positive or this only negative. So we don't have like, if it is connected to the positive terminal, it will act as a positive. Next one is what? Negative. Okay. So next one from this, what is ideal ammeter? Okay. So ideal ammeter means what? It's a whose resistance is what? 0. Okay. So whose resistance is equals to what? 0. And how do you connect the ammeter? Ammeter is connected in what, ma? It connected in what? Series combination. Okay. So it connected series combination in the circuit. Okay. So this is what? Series combination in the circuit. Like, so magnetic effects means electric current is this, is the electric current. So related information about the electric current we have completed. And so when you speak about this electric current, when current is passing through any conductor means what? Wire. Okay. So through any wire, it acts like a magnet. So when it acts like a magnet, around this magnetic field is what? Created. Okay. So just if you see this one, for example, this when current is passing through the conductor. Okay. This is the direction of current. Yes. So usually for the current through the cross section of a conductor, when you see this is the conductor. Okay. So through this is the cross section. This is what? It's a cross section. Through this cross section, like this, the charges are flowing, positive and negative charges. Okay. So in the direction of positive charges, current will be flowing. This is the direction of current. So what do you say from this? Current direction is what? Okay. This is what? Current direction. Current direction is in the direction of, so in the direction of positive charges. Okay. So this is what? In the direction of positive charges. Like we can talk on this about, so it's what? Direction of current. Okay. So next one after this, So when it is passing through this one, according to the scientist, who is that? So Orested. So Orested's experiment. Okay, Orested's experiment. What is the Orested's experiment? Orested experiment is what he has taken as a circuit. The circuit is in current electricity we have completed. What is a circuit? Circuit means it's a simple circuit. Simple circuit means it should consist of, okay, so from this is in his experiment we have that first one, there is what? A simple circuit. Okay, simple circuit. Simple circuit consists of what? Okay, so just what according to, just I'm taking as first one is what? Simple circuit means what? It should contain energy source. Okay, next one, energy consumer. Next one, connecting wires. Okay, and key, plug key or tap key. So key can break the circuit or key can make the circuit. Okay, so just I'm using for this, here is the some circuit is mentioned. Okay, so just you can talk about this. It has the resistor. Okay, is the resistor, like this is what resistor, and some ammeter is connected. Okay, next one, it is connected. So this is what? Battery. Okay, like this, it's a battery. Yes, and next one, after this some key is connected. This is the key, like we can keep in the circuit. Circuit is closed. Circuit is closed means it's a dot. So it's a closed circuit. This is what? Closed circuit. Yes, it's a closed circuit. So it's a positive and a negative. This is what? Totally, this total thing is what you say? It's a battery. Battery is what? Combination or group of cells. Okay, how many cells do you have? 1, 2, 3. Okay, so like these 3 cells are there. 1 to 1 are connected. Like for example, first one potential is V, 3 are connected, 3V. Our first one potential is 2V, 3 are connected. What is it? It's a 6V, like this one. Okay, so what is the direction of current passing? Like this is the direction of current passing in the circuit. Okay, so yes, according to Orested's condition, Orested's experiment. So what is the Orested experiment? He has taken, just imagined a plane. A plane means what? He has taken a paper. This is what? Like a paper. Yes, so here is the point with respect to this point. With respect to this point, just imagine the wire is passing through the paper. Wire is passing through the paper like this. On this I placed the compass. Okay, this is what? Compass. Compass has, so like it has a compass. This is what? It's a compass needle. Okay, so compass needle or magnetic needle. Compass is like this. Okay, so this is here for everything compass. It will be directed on the screen only. And next one, this is what? Here some, here magnet, a small magnetic needle is placed on the screw. Okay, magnetic needle. This is a magnetic needle which is showing here. This is what? It's a north, and this one is what? It's a south pole. This compass is placed on the paper. Okay, very first condition, he conducted the experiment. The experiment is what? There are the 2 things we need to learn. So first thing is what? Here when this is what? Opened, when the circuit is what? Opened. If you say this, this is the circuit. It's a opened circuit. Opened circuit means what? No current is passing. No current is passing means this is what? It's a, what is a magnetic needle is here. Like this you can see, this is what? Magnetic needle. Yes, generally, for example, magnetic needle, okay, magnetic compass, when it is placed on the surface. On the surface means what? If you place on the paper, if you place on the, so this in the absence of any external magnetic fields, just if I place on this one, so it shows what? Geographical north and south pole. Take a bar magnet. This is a bar magnet. For the bar magnet, if you suspend this one, it shows what? North is pointing towards what? It shows the geographical north and south pole. Okay, so for every compass, whichever you are placing on that one, it shows what? A geographical north and what? South poles. Okay. Now this same compass is placed here. Now I am allowing the current to pass through it. Means what? Switched on the circuit. Circuit is switched on. Switched on means what? Current. So this is what? Switched on. Yes. So it's a switched on, in the switched on circuit, in the on case. So the current will be passing like this direction. Yes or no? So when current is passing through here, then this part here, whichever you are talking about, this everything is there, but I am taking about this part. It acts like a magnet. It acts like a magnet means what? Magnetic field is created around this one. Yes, magnetic field is created. So when magnetic line of force is interacting with this magnetic line of force, magnetic field line, anyone, magnetic line of force or magnetic field line, so which is interacting with this magnet, means what? In the compass it deflects. Okay. So he observed that it's showing the deflection. Deflection means what? According to Orested, he said that, and then when it is switched off, then there are no deflections. When he switched on this one, there are deflections. He observed that. And second case is what? This is the first one. Second one is about, so these terminals are changed. Okay, terminals are changed. So terminals are changed. So what are the terminals are changed here? Changed means what? This positive, it's the total the circuit what? What do you say? Battery is reversed. This will become as positive. This will become as negative. The deflections, what he observed, that the deflections are what? It's complete. Again, different directions are there. In opposite directions are there. So from this, he concluded that that's what here every current carrying conductor. Every current carrying conductor. So every current carrying conductor acts like a magnet. So it acts like a magnet. Okay, it acts like a magnet. This was the statement by what? Oersted's experiment. Next one, after this Oersted experiment, it leads what? Just it makes us to learn about this. So current carrying means what? Current carrying conductor acts like a magnet. Let me know about what is magnet. What is magnet? Yes, first thing is about, this is what? The magnetic substance is different from the magnet. Yes. So magnet, this, when you speak about this magnet is what? Like different shapes of the magnets are there. This is the magnet. What is the shape of this one? Rectangular shape. So this is called what? Rectangular magnet. Careful on this. So rectangular magnet. So rectangular magnet is, so this is what? Rectangular magnet. Rectangular magnet is called bar magnet. So this is called, it's a bar magnet. Okay, this is what? Bar magnet. In the bar magnet, so it's what? This length from here to here, which are the lengths? This is what? A and B is called geometrical length. Okay, geometrical length. So this length is what? AB. And its pole strength, this is called pole strength. Pole strengths means what? Denoted by small letter m. Pole strengths are, so little closer, little inside this one from the actual length. So this is called what? This length is called what? Magnetic length. Okay, so it's a magnetic length. So this is magnetic length. So what is the magnetic length? North and south pole, NS direction. Magnetic length means what? NS. And geometrical length is what? From this you can say, one is what? Magnetic length. Okay, magnetic length. And next one is about, what is the magnetic length here? NS. And geometrical length, so geometrical length. So this is what do you say? It's in A B is the magnetic length and geometrical length. Do you think both of these two are same lengths? No, definitely they are the different lengths. Okay, magnetic length is equals to 5/6 times of geometrical length. So this you will learn in the next levels. So here is what magnetic length, and another one is about this geometric length. First question to us, what is the magnetic field line, or what is the magnetic line of force? Line of force or magnetic field line. Next question is about what is the magnetic field. Yes, so next one, if you see about, first one is about magnetic field line. Yes, magnetic field line. So magnetic field line is just, so if it as a activity or as an experiment, if you want to do this one, take a bar magnet or take any magnet, just make a move in a sand, then what happens, it is completely covered by a black grayish dust. Okay, so that means what, the powder which you are taking about from that, you place on the paper, and below the paper you place a magnet, so that it forms like what, this is, it's a north, next one is the south. Magnetic line of force will be directed like this. This is what magnetic line of force. Magnetic line of force is what, directed from the north pole to what, it's a south pole. You can see from the picture, no two magnetic lines of force are intersecting with each other. Yes, so this line is going on like this one, this line is like this one, this line is like this. Yes, so what is the meaning of this? They are coming from the long distance. This is a direction like this, okay, is south, north and south. You know, so this north and south, from this magnetic line of force, where they are coming from ear to ear, from inside from south to north. Yes, inside from south to north. Outside from where? Outside from, so north to south. My first question is about what is magnetic field line? What is magnetic field line? First of all, can you see the magnetic field line around the magnet? You can't see. Yes, so magnetic field line is what, it's an imaginary line. So this is what, imaginary. So imaginary line. So imaginary line. So which is directed, which is directed away, which is directed away from where? Away from north pole, away from north pole. Yes, so which is directed away from north pole. Yes, north pole, and towards to what, south pole. Yes, so this is what imaginary line. That's what first definition is completed. So what is the magnetic field line? Magnetic field line means what, it's imaginary line which is directed from the north pole to south pole of a magnet. Yes, next one about what is the direction of magnetic line of force? Externally. Yes, so externally, so externally from outside, from where to where? North to south. Internally, okay, so it's what, internally, so this is what, from the south pole to north pole. Yes, this is what magnetic field line. And so can you make the question this one? So can you imagine two magnetic lines of force intersect with each other? No. Okay, so when two magnetic lines of force intersect with each other, at the point of intersection, the field has many directions, which is not possible. Okay, so that I can say no two magnetic lines of force intersect with each other. Okay, so with each other, this is about magnetic field lines. So magnetic field lines are magnetic lines of force. So what is the definition for this one? Imaginary lines which are passing from the away from north pole or towards to the south pole. Yes, so magnetic lines of force, what is the direction of north pole? What is this magnetic line of force? It's away from the north to south, externally. Internally from where? South to north. And next one is about, so no two magnetic lines of force intersect with each other. Yes, so Next one, what is the magnetic field? Magnetic field. So magnetic field. Magnetic field is B bar. So careful on this one. What is a magnetic field? Magnetic field also called magnetic field strength. Yes, so magnetic field strength. So magnetic field is also called what? Magnetic field strength. It is a B bar I am writing. What does it mean? It's a vector quantity. Yes, so this is also called what? Magnetic field strength. Magnetic field strength. Okay, so magnetic field strength. Magnetic field or magnetic field strength. How do you define this magnetic field strength? B bar is equals to, yes, F bar by what? It's a M. Careful on this. B bar is equals to F bar by M. So B bar stands for what? Magnetic field. F bar stands for what? Magnetic force. M stands for what? Pole strength. Yes, so you can please continue writing. This is what? It's a magnetic field. So magnetic field, and it's a magnetic force. Magnetic force. Next one, this is called pole strength. It's a pole strength. Yes, but magnetic force is measured in what? Newton. Magnetic force is measured in what? Newton. Pole strength is measured in what? Ampere meter. Don't say ampere minus meter. It's a ampere meter. Magnetic field. So what is the unit of this one? So its units we can say. The units are what? Newton per what? Ampere meter. So the unit of magnetic field is what? Newton per ampere meter. What is the nature of this? It's a vector quantity or scalar quantity? Vector quantity. Yes, it is a vector quantity. So this is what? Vector quantity. Vector quantity means what? Should has the both magnitude and direction. Yes. Now come to the point. So how do you define? How do you define this magnetic field? Just you come to the point. Just I'm talking about just a small activity, like I'm choosing a small bar magnet. It's a north and south pole. Yes, so north and south pole. So the field line, the magnetic field is what? Around this one something is there. This is around this one, and next line. This is what here? No attraction and repulsion. That is the center where there is, it's a neutral point inside between these two, so there is no attraction and repulsion. So for example, if I choose another bar magnet, it's what? North and south. Yes, so like this is there. This is the case. So my question is about here, when if I place any bar magnet near to this one, what is this? North. Next one, north. North, south. Okay. Next one, south, north. Next one, south, south. Okay. These two are called what? Like poles. Yes. These two are called what? Unlike poles. Like poles and unlike poles. Like poles are repelled or attracted? Repelled. Okay. So like poles are repelled. These are what you say, ma, this. So unlike poles are attracted. So my question is about, when you choose the two bar magnets, when these two bar magnets are far away, do they attract with each other? No, because the fields are different. When they come here, its lines of force, what happen? Interact with each other. Then either attraction or repulsion can takes place. Yes. So this, how do you define the definition for this? This is what? It's a space or region. Space or region around the magnet. Space or region around the magnet. Space or region around the magnet. Around the magnet. Okay. To attract or repel. So repel by other pole of magnet. Okay. So other pole of magnet. This we can say it's a magnetic field. Mathematically, magnetic field is defined as what? Magnetic force per what? Magnetic force per pole strength. Yes, magnetic force per pole strength. Unit pole strength is the correct statement. Yes, magnetic force per unit pole strength. Otherwise, this is defined as this: the space or the region around the magnet, okay, to attract means what? What region the attraction or repulsion can exist, that region is called what? Magnetic field. You know one thing, when number of magnetic field lines increasing, magnetic field lines increasing means flux increasing. It means what? It's a flux. Okay, so magnetic field lines increasing, magnetic field increases. Magnetic field lines are only 2 are there, field will be less. Magnetic fields are 10,000 there, so magnetic field will become as what? It's a more, it's a bigger one. Yes, so this is B bar is equals to F bar by what? It's a M. So this is about magnetic field. Next most one, so he may also ask the question to you. So find, draw the diagram of that magnetic lines of force around the bar magnet. Yes, so check up to here.